Okay, so in this video, we're going to talk all about using inverse trig functions and just basically doing a lot of problems with them. So first, we're going to look at using our calculators to find values of inverse trig functions. And of course, I'm going to tell you to pay attention to if you need to use radians or degrees. So if you look at this first set of problems, so I just want to point out, one is telling us to use radians, the other is using degrees. And okay, so let's look at these problems. I've got y equals inverse secant of -4 and then arc cotangent of negative 2.25431. All right, so first notice that we can't enter either function directly into a calculator. So, right, I've got inverse secant, inverse cotangent. There's no button on the calculator for this. And I want to clear up some common confusion about this. So forget about inverse trig functions just for a moment. Let's just think back to regular trig functions. So what if I wanted to do something like finding cosecant of 30 degrees? So how would you find this in your calculator? You enter 1 divided by sine of 30 degrees. Why? Does that make sense? Why? Well, it's because cosecant of x, this is the property, right? It is equal to 1 over sine of x. That's why. So now, to evaluate inverse functions, this gets trickier. So first, I just want to explain to you, your calculator is going to view the domains. It's very strict about the domains of inverse trig functions. So I want to call this to your attention. Look at the domain of inverse cosine. It's from -1 to 1, but look at the domain for inverse secant. It's literally the opposite, right? It's from -infinity to -1 and 1 to infinity. So these are like almost opposite domains, right? So there's an issue in that I can't just enter whatever I have for secant in, because the domain for secant is the complete opposite of cosine, even though I know these are reciprocal functions, right? And the same can be said of sine and cosecant. Again, these are reciprocal functions, but look at their domains. They're like totally the opposite of one another. So, all right, that's an issue. So in other words, our calculator will get mad if we try to just enter this in. So if I try to just treat, secant, inverse secant as inverse cosine, this is going to give me an error. And by the way, I want you to prove this to yourself. So try to enter this into your calculator. 1 divided by inverse cosine of -4. So put this in, you should get a domain error. And make sure, by the way, that your calculator is in radians. So your calculator is going to get mad at you for this. Okay, so let's think about this. I want you to understand why this is different. All right, so let's just focus on this part of the unit circle. So where I have 30 degrees or pi over 6, I have this coordinate. So I just want to think about this for a moment. This point, square root of 3 over 2 and 1/2. All right, so we know, right, the x coordinate, this stands for, what this stands for, this coordinate, this stands for the value of cosine of pi over 6 or cosine of 30 degrees. This would be what I read for my cosine. This would be what I read for my sine, right? So we know this. We've been talking about this a bunch. And then we've been talking about with inverse sine. So inverse sine, I now kind of go backwards with the coordinate, right? So I read this part of the coordinate, and then I know that this will be the value of the inverse sine. Okay, so now let me ask this question. What if I want to know the value of inverse cosecant? So this is all going to be connected in a moment. So let's think about inverse cosecant of 2, not -2, just 2. All right, so let's think for a second. Inverse cosecant of 2 equals y. What does this mean? By definition, the definition is we are looking for this value where cosecant of y equals 2. That's what it means to be the inverse function. So we're trying to figure out what value of y would give us 2. All right, so now that I'm thinking of it this way, I can manipulate this. Cosecant of y is equivalent to 1 over sine of y, right? So these two expressions are the same thing. Okay, so now I have 1 over sine of y equals 2. All right, so what I'm going to do now is I'm going to try to isolate this sine of y. So right now this is in the denominator. So let me multiply both sides by sine of y. And so now I get 1 equals sine, or 2 times sine of y. I'm trying to isolate sine of y, so let me divide both sides by 2. So check this out. Now I've got sine of y equals 1/2. And now what I want to do is I want to solve for y. I promise you this is going somewhere. Okay, so here's where we're at. and I'm trying to solve for y. Okay, so to solve for y, I would use the inverse sine function, right? That's technically what I would do, so use the inverse sine function. So I'd have inverse sine of 1/2 equals y. Okay, so look what we just did. We just used a bunch of different properties of inverse sine and reciprocal functions, and we just did something kind of amazing. I just showed that inverse cosecant of 2 is equivalent to inverse sine of 1/2. So, do you see why this might be confusing? Maybe, maybe not. All right, so wait, let's go back. Remember when I was saying cosecant of x was equal to 1 over sine of x? Let's compare. This is why this is confusing. For regular trig functions, if I have like cosecant of 35 degrees, if I wanted to figure that out, in the calculator, I would put 1 over sine of 35 degrees. And now what I'm telling you is for inverse cosecant, to figure that one out, I do inverse sine of 1 over 35 degrees in the calculator. Yeah. All right, so that's kind of confusing. I'm not allowed to say this on camera. So let's write that down and make a little cheat sheet. All right, so inverse trig functions not on the calculator. Here's your cheat sheet for this. If I have inverse secant, what I'm going to enter in my calculator is inverse cosine of 1 over x. So whatever this x value is, I take that reciprocal. Inverse cosecant, I take inverse sine and 1 over x. And now here's like the one that's totally going to mess with your head. Inverse cotangent. This actually breaks into just two separate cases. If x is greater than 0, then you can just do inverse tangent of 1 over x. But if x is less than 0, then you have to do 180 degrees plus inverse tangent of 1 over x. And if you're in radians, then you have to convert this to radians. So this would be pi. Okay, now let's compare that to regular trig functions. I think it would be very good at this point to have a cheat sheet comparing both. So this last one was for inverse trig functions. So now let's just review regular trig functions. So secant x is 1 over cosine x, cosecant of x is 1 over sine of x, and cotangent of x is 1 over tangent of x. So I would suggest that you pause and write all that down. Actually, I'll show you one more time too. If you need to pause here or pause here. Okay, so now that you get that, now we can go back to this. So how do I do this? Okay, so these are inverse trig functions. So if I wanted to do inverse secant, so then I'm going to take inverse cosine of 1 over x. So in this case then, I'm going to write in my calculator inverse cosine of negative 1 over 4, okay? And so then if I do that, so remember, make sure your calculator is in radians. It's a lot to remember. I think it's very easy to make a mistake with this, even though you're using a calculator. So this is what you would get in radians. And now, let's make sure that you got that. Now let's compare with degrees. Okay, so now I've got arc cotangent of negative 0.25431. So in this case, now I'm going to use this crazy case because I have my x is a negative number, so x is less than 0, so I have to do this 180 degrees plus inverse tangent of 1 over x. So this will be the calculation then that I need to do. And in degrees, this comes out to 104.268425. Okay, good, good. All right, so now let's just try a couple other problems here. I would actually recommend that you pause the video. One thing I want to mention is, since we're not told otherwise, just assume we're in radians. I would suggest you pause the video here and just try these two on your own and then hit play when you're ready. Okay, so for this first one, so you should just be able to enter this straight into your calculator. Sine of inverse cosine of 0.25, so in radians, this came out to 0.9682458. Now, this second one, this one is going to require that you keep your regular trig functions and your inverse trig functions straight. So this is cotangent, so to evaluate that, what I'm going to do is I'm going to take 1 over tangent of, so inverse cosine, I can just enter straight in my calculator. So here's what I'm entering into my calculator, and that comes out to 0.68177. Okay, so now let's pivot and evaluate without a calculator and just talk about how to work from that angle. All right, so the first example we're going to look at is to find the value of the cosine of the inverse sine of 2 over 3. And so if you think about it, 2 over 3, right? So this is not one of the coordinates on the unit circle, but no worries, we got this. So what we're going to do, of course, is first we're going to have to think about what quadrant are we in. So this is positive, and then if you just think about the intervals for inverse sine, this is going to be in the first quadrant. And so then, of course, I'm going to tell you to sketch. So, all right, here is an angle in the first quadrant, and this is inverse sine. So we can really view these as the sides of, kind of our reference angle, or the triangle that we usually create right from standard position. So we've got opposite over hypotenuse, 2 over 3. So we've got those sides. And so then to finish this, you can just use the Pythagorean theorem to figure out this side here. So square root of 5. And so now this is, we can see like inverse sine of 2 over 3 would give us this angle theta. I don't actually have to know what the value of theta is. I just now have to find cosine of theta, and I have enough information to figure that out. That comes out to square root of 5 over 3. So you see how that works? Okay, so let's do that again for secant of inverse secant of 2. So I just want to approach this like from two different angles. So first of all, we are composing a function with its inverse. So there's this property here, f of its inverse will just equal x. So this should just equal 2. But if I want to just think about how is this going to work, so once again, we're going to be in the first quadrant. And okay, so in this case, secant, so that's going to be the hypotenuse over the adjacent sides. This will be 2 over 1. So then if I wanted to just take secant of theta, so then I literally just take those sides again, right? Secant of theta will be 2 over 1, so this just equals 2. So no matter which way you want to think about this, and probably the easiest way is just to know, it's the function composed with its inverse, so it equals 2. But either way, we've shown also from a graphical standpoint that this equals 2. Okay, so let's just do a slightly harder example. So sine of this crazy thing. All right, so what we're going to need two sketches. So you're going to want to have a sketch of this inverse tangent 4 over 3 and this inverse cosine of 12 over 13. So if you're watching this, of course, you're trying to get this. I would recommend that you sketch and then complete the sides of the triangles. So do that first and then hit play when you're ready. Okay, so I went ahead and sketched these out. So these are both going to be, they're both positive, so they're both going to be in Q1. And okay, so I have, so tangent, so that's opposite over adjacent, so 4 over 3. Cosine, that's adjacent over hypotenuse, so that's 12 over 13. And then I can just fill in the other sides, so I get 5 for the missing sides. Okay, so now I'm actually going to view the value of this as A and the value of this as B. And the actual value of the angles does not matter. So it doesn't matter because we're ultimately going to take the sine of these. So what we're going to do now is I'm going to call this A, this B. So now what I'm really going to evaluate is sine of A minus B. And you might remember, right, that we had an identity. So sine of a difference, bada bing, bada boom. So I need to use this guy right here. All right, so I go ahead and I just set this up. And so from here, what I'm going to do is I'm going to find each one of these using my picture, and maybe just the other thing that I want to do. Remember this angle here, I called it theta before. Let's call this angle now A, and this angle here B. And so I just now need to find sine of A, cosine of B, cosine of A, sine of B. So you should actually be able to finish this, right? You have enough information to finish this. So I would suggest that you pause the video here and you try to finish this and see if you get it, and then hit play. Okay, so I go through and I just fill everything in. So sine of A is 4 over 5, cosine of B is 12 over 13, cosine of A is 3 over 5, and sine of B is 5 over 13. So if I go ahead and I just finish that, I get 33 over 65. So that would be how you'd approach that problem. Okay, and so for these last exercises, it says write each expression as an algebraic expression in terms of u. So we want to write these, I'll just jump right into it. So we're going to assume that u is greater than 0. So that is going to allow us to just consider our graphs in Q1. So that's kind of important. And then, of course, duh, we want to sketch always. So, okay, I need to sketch this situation. So it's some, curve in Q1. And so this is kind of like the previous problems we were just looking at, except instead of having numbers, now I have u. So I can think of this as u over 1. So inverse secant, so secant, that's referring to the hypotenuse over the adjacent side, right? So u over 1, that would mean that u is my hypotenuse, and then the adjacent side, this is the unit circle, so you can just assume if you have no other information that this side is 1. Okay. And then I got to figure out the other side, right? So I just used the Pythagorean theorem. That becomes the square root of u squared minus 1. And so then when I want to find cotangent of the inverse secant, that's really equivalent to just finding now the cotangent of my theta. And I can just read that straight off of the sketch. So I just need to take now the adjacent side over the opposite side. So I get this here. And then, of course, I've got to rationalize. So then that comes out to the square root of u squared minus 1 over u squared minus 1. Okay, so I've got one more of these, and I know this looks a little bit more complicated. We still want to assume here that u is greater than 0, and I think that you should try this one, so try to sketch everything. Seriously, you're not going to get as much out of this if you don't try to sketch it yourself, and yes, you do need to make the sketch. So I suggest that you pause the video here, try to finish this, hit play when you think you've got it. Okay, so I've got my sketch. So cotangent, so this is going to be looking at the adjacent over the opposite side. So this is my adjacent side, this is what my opposite side is. And then I need to find the value of my hypotenuse. And so it's a little crazy looking, so I just put all the math here in case you wanted to check the math. The hypotenuse should come out to 2, and if you want to just double check the math, you can pause the video and read. I put all the calculations down here. Okay, so now I just need to find secant of theta. That's really it. That's the last part of this. So secant of theta, so that's going to be the hypotenuse over the adjacent side, and then I just have to rationalize. So that comes out to 2 times the square root of 4 minus u squared over 4 minus u squared. Okay, and so that brings us to the end of this video. So that was just a lot of different types of calculations and evaluations we can do with inverse functions. So hopefully that was helpful. If you found that helpful, please consider liking the video, commenting, sharing with your friends, or subscribing to the channel. And otherwise, thanks for watching, guys. I'll catch you in another video.